My dear students, today we will study chapter number 1, number systems. Now, this chapter, number systems, is based on different patterns of numbers such as natural numbers, whole numbers, integers, rationals, and irrational numbers. So, one by one, we will discuss all these definitions. So now, the first definition that we will discuss is natural numbers. So I'm writing over here natural numbers. Now, what is natural numbers? The counting numbers are called natural numbers. Natural number starts from 1, then comes 2, 3, 4, and in the end what we write? Infinity. Now what is this infinity? So infinity is something which does not have an end point. Infinity is something which does not have an end point. Now the collection of natural numbers is represented by letter capital N, and this is equal to, now see, I am putting a brace over here. The first number that I will write is 1, then I place comma, then 2, then 3, then after that I put 3 dashes, and in the end I will write infinity, and again I will put a brace over here or curly bracket. So in this way we represent the collection of natural number, where smallest natural number is 1, and we cannot describe the last natural number. That is why I have written infinity. Now if someone asks you that how you get this infinity, you can say like this. What is infinity? Infinity is any number in bracket you can write except 0 upon, what is infinity? Any number. Exception is what? 0. In numerator we cannot write 0. Upon 0. For example, suppose somewhere you get 1 upon 0, and this 1 upon 0 is what? Infinity. Suppose you get somewhere minus 2 upon 0, then directly you can write it as infinity. Now why I have written this exception as 0? The reason is because if anyhow in numerator you get 0 and in denominator you already have a 0, then this 0 upon 0 will be called as an indeterminate form. Once you get this indeterminate form, then you apply L'Hospital rule. But the problem is that these things are higher classes syllabus. So right now we will concentrate only in this portion. Now this next definition is whole numbers. Now what are whole numbers? If 0 is added to the collection of natural numbers, if 0 is added to the collection of natural numbers, then the new collection obtained is called whole numbers. We represent this whole number by letter capital W. Now the smallest whole number is 0, so I have written 0 over here, then I have placed a comma over here, then I will write 1, 2, 3, 4, then I will put 3 dash, and in the end I will write infinity. So this is the definition of whole number, and this is the way of representing whole number in set form. W is equal to, put a brace over here, 0, 1, 2, 3, 4, dash dash up till infinity, then again put a brace. Now the next definition is integers. So I am writing over here integers. Now what are integers? Now in definition of integers is like this, that if negative natural numbers are added to the collection of whole numbers, if negative natural numbers are added to the collection of whole numbers, then the new collection obtained will be called as integers. We represent integers by letter capital I or capital Z, and this is equal to, I am putting a brace over here, and suppose I am putting a brace over here, then in the middle I will put a 0. To the right of 0 I will write all the natural numbers 1, 2, 3. Then I will put 3 dashes over here, and in the end I will write infinity. To the left of 0 I will write negative natural numbers -1, -2. Then I will put 3 dashes over here, and over here I will write -infinity. So what I have told you, that if negative natural numbers, you can see over here, this is the collection of negative natural numbers. If negative natural numbers are added to the collection of whole numbers, if negative natural numbers are added to the collection of whole numbers, then the new collection obtained will be called as integers. We represent integers by letter capital I or capital Z. So right now we have discussed the definition of integers. Now in this collection you can see that between 0 and 1 there can be number like this 1/2. Between 1 and 2 there can be number like this 3/2. Between 0 and -1 there can be a number like -1/2. Between -1 and -2 there can be a number like -3/2. Now these numbers are following ratio pattern. These numbers are following ratio pattern, and such numbers are called rational numbers. Such numbers are called rational numbers. So our next definition is rational numbers. Rational numbers. Now what are rational numbers? Definition is like this: any number which can be expressed in the form of P/Q. Any number which can be expressed in the form of P/Q, where P, Q are integers, where P, Q are integers and Q is not equal to 0, are called rational numbers. Are called rational numbers. Are called rational numbers. Now, in set form, the collection of rational numbers is represented by letter capital Q, and this is equal to, in braces I am writing P/Q, such that P, Q, now this is the symbol of belongs to, where P, Q belongs to integer, comma, and Q is not equal to 0. So this is another way of representing collection of rational number in set theory form. P/Q such that P, Q belongs to integer and Q is not equal to 0. Now we will discuss examples related to rational numbers. So first example is 1/2. Now the question is this a rational number? Yes. The reason is because P and Q both are integers and Q is not equal to 0. So this is a rational number. Now Suppose if I am writing minus 3 upon 2. Is this a rational number? Yes. This is again a rational number. The reason is because minus 3 as well as 2 both are integers. Also, this 2 is not equal to 0. So this is again a rational number. In the same manner, is 1 a rational number? Yes. Why? Because this 1 can be written as 1 upon 1. And if I write this one in the form of 1 upon 1, so both p and q are integers and q is again not equal to 0. So this is also a rational number. Now one more example. Is 0 a rational number? Now see, what I am doing is I am placing 1 below the 0. Now, and it makes no changes. Now see, 0 upon 1. 0 is integer as well as 1 is also integer. Correct? And this q is not equal to 0. So again we can say that this 0 is also a rational number. Now one more thing is that natural numbers, whole numbers as well as integers, these are all natural number, whole number and integer, these all lie inside rational numbers. Natural number, whole number, integer, these all three collections lie inside the set of rational numbers. Hope you have understood the lecture.